Okay, in this section, we are going to introduce imaginary and complex numbers, and I am not going to go through every bit of every part of these notes, so I just want to be sure that you understand. Just fill in the parts that we go through, and that will be the part that you need to practice on your assignment. So first of all, let's talk about imaginary numbers in general. Remember at the first of the year, and I drew this little diagram up here at the top, we drew the number system, and we said number systems were created, right, based off of what numbers they needed to progress civilization or to use in business transactions, whatever it was. So the natural numbers were the first ones, right, just counting numbers. Then we added 0, we call those the whole numbers. Once we have negatives involved, we call those the integers. When we add fractions in, right, now we start cutting things in fractions. We have the rational numbers, and then suddenly they ran into situations where there were irrational numbers, numbers that went on forever. So instead of having to write those, you can imagine as before a calculator, they created this symbol called the square root, right? So if you have like the square root of 3, that's an irrational number that lies somewhere between the square root of 2 and the square root of 4. So square root of 3. This creates the real number system. Now, that worked really well for solving equations for many, many, many years. But eventually, we get something like when we build equations, a squared is equal to negative 9. Now, if I'm trying to solve this, a squared is equal to negative 9, right? We would say, well, what squared equals negative 9? Well, it's tempting to want to say, well, negative 3, right? Negative 3 squared is negative 9. But that's not true, because negative 3 times negative 3 is a positive 9. So that actually doesn't work. And positive 3 squared definitely won't give us that negative 9. So in essence, for a long time, this is what we would just say, well, there's no solution. There are no numbers that account for this. And mathematicians had a really hard time finding all of these equations that had no solutions. Eventually, they create and accept what we now call imaginary numbers. And imaginary numbers, they are related to that situation like this. So we're going to talk a little bit about that. And imaginary numbers stemmed us into creating what we call complex numbers. Imaginary numbers started to behave very much like real numbers and follow the same rules. And so when we have a real number plus an imaginary number, which is a number with this little I that is used to represent that, that creates a complex number. So our goal today is to be able to deal with imaginary numbers and use them nicely, and then perform operations with complex numbers. And again, they behave very much the same way as real numbers, which is why mathematicians eventually accepted them. So let's start with defining imaginary number. An imaginary number is a quantity of the form a times I, right? So there's a little I going to be involved. That's the symbol of the imaginary number, where a is a real number and I is the positive square root of 1. So for example, if I had something like the square root of negative 4, that really could be written as the square root of 4 times the square root of negative 1. Correct? We just did multiplication. If you multiply those two together, again, you get the square root of negative 4. So all of those really represent the same thing. Well, mathematicians, instead of writing the square root of negative 1 over and over and over again, they said, well, let's just call this the symbol I. So now I can take this same thing and I can write I square root of 4, right? That's like the square root of negative 1 represented with the I multiplied by the square root of 4. However, we know that the square root of 4 is just 2. So when this breaks down, we end up with bringing the 2 out with the I, and we don't need the radical anymore. So 2I would be an imaginary number. So any number you see that's written as like 10I, we know that that's an imaginary number. That instead of writing 10 times the square root of negative 1 over and over and over again, we just write 10I. Complex numbers are any numbers, again, that have a real part and an imaginary part. So instead, again, of writing complex numbers in this way with the square root of negative 1, we just write an I there instead. So they look like they have a real part and imaginary part. Now let's talk about where the I comes in when we're simplifying a radical, because it's not always there when there's a negative. I'm going to revisit our example up here at the top that had no solution. What if we were to look at, instead of a cubed equals -8, right? Now we're saying what number cubed, or what number times itself again, would give us -8. Now, because of the way negatives behaves when you multiply, a negative times a negative is positive. But if we then multiply it by a third negative, it will be a negative value. So when we have cube roots, right, we actually can find cube roots that have negative outputs. So it's only when we have an even number of these little factors that are going to multiply together. They keep multiplying in pairs, creating positive numbers. But if we have an odd number that we're looking at, then -2 times -2 is +4, but when I multiply it by a -2, it then becomes -8. Okay, so down here it says our imaginary unit I is where I is equal to the square root of -1. Okay, we use the imaginary units to simplify even roots. Okay, that's really important. Again, as we just looked at odd roots, they can have negative outputs, meaning the root has an even value as its index. So we always, we're going to practice this on the assignment today, look at the index first, with negative radicands. So for example, as we go through these, we always look to see, and maybe that should be step 0 before 0, step -1 or something. But essentially you want to look, so you're going to look to see if the index is even or odd, okay? Just to glance at it. Then you're going to move the negative out of the radical. So if there's a negative in the radical, we get rid of that first before we simplify. And we move it to the front, okay? It goes to the front, and we represent it with an I. Now, again, if it's an odd index, then we represent it with a -1. It just comes out as a negative instead of an I. So let's walk through a few of these. I look to see again at the index. There's not a number written there, so this is an even index. It means it's an index of 2, right? So in this case, I am going to write the negative out front as an I. Again, I could write the square root of -1, but to make this nicer and easier to write every single time, we use the I. Then we could break down the 9, which is 3 and 3. So it looks like, actually, I won't even need that radical anymore. So we can erase the little radical because everything comes out. And it looks like we're just going to have 3i. Okay. Again, we look at the next one. This index here is an even number, so that means this negative is going to come out as an I, okay, and then I'm going to not have to worry about the negative, and I can break this down like normal. So this would be like 6 times 4, 2 times 2, 3 times 2, and the index is 2, so I need a group of size 2. So this 2 gets to come out and multiply by the coefficient that's already there. So that would be like 2 times 2, which is 4, and the I is out there. And then the leftover is that 3 there and that 2 there. So we multiply 3 and 2 and put the 6 back in. Again, it's simplifying radicals just like we've practiced. We just have to look to see if we need an I or not. Again, if you look at the next one, this one doesn't have anything written there. So this is an even index. So when this comes out, it is definitely an I. And then we have the square root of 10. 10 doesn't break down. We have 5 and 2, but there's no groups. So we know that it'll just finish at the square root of 10. The next one, again, I'll just do a couple more of these. Again, this is an even number, so now it's a 4, so we need bigger groups to pull things out. But this negative is going to come out as an I. It will in no way affect the negative that's already out there. It just allows us to get rid of that negative on the inside of the radicand. The 8 definitely won't break down with 4. We're going to get 3 2's, so we can't break that 8 down. But let's see, there's 5 x's, so we can make a group of 4 there with 1 extra. So let's pull an x out with that I and the 3, so -3xi. And then inside the radical, and we want to make sure that index comes with the radical, that 8 had to stay in there, and this leftover x is also in there. Okay, so what happens then if we have an odd index, right? If there's an odd index here, this is where the negative can be allowed to come out as a -1. So when this comes out, it's like having a -1 out front. So in this case, when I start to break this down, I get 3 and 6 and 3 and 2. I need groups of size 3, so there's not a group there. Oops. And then I have 3 x's, so they make a group. So the x gets to come out with that -1, so we're going to have negative x or -1x if you want to write it that way. And then we have 18 on the inside. Okay. So what happens if we are looking at imaginary numbers and we want to perform some operations with them? When we add imaginary numbers, it works pretty easy because we just add like parts, and I'll show you that. When we multiply them, though, sometimes we'll get like I squared, just like we end up with x squared. So let's talk about what would happen there. So again, if we have I down here, and I'm looking at this first row here, I is equal to the square root of -1. So when he shows up in an equation, he just looks like an I. Now I squared, if you imagine, is just this same thing, but squared. And remember, when you square a square root, those are the opposites. So it actually just cancels each other out and leaves you with -1. These are the two big ones that we're going to use. So if you have an I in your equation, that's totally fine. We should leave that in the equation. If you have an I squared in your equation, you want to simplify it down and substitute a -1 to keep simplifying. So let's kind of jump over and look at what that looks like. So we're on the second page where it says operations with complex numbers. And again, when you add and subtract complex numbers, these are going to be your favorite numbers in the whole world because they only have two types of terms. They either have real pieces that add together because they're like terms, or they have imaginary pieces that add together and they're like terms. So you'll notice if I was adding these ones right here, I would take the two real parts, the 3 and the 4, and add them together. That would give me 7. I would take the 1i minus 9i, that would give me -8i. So let's just do one or two of those. Again, if we look at A here, we have a 4 and a +10. So we're going to get 14 as our real piece. We have a -7i plus 3i is -4i. Okay. Whether they're in parentheses or not. So like this next one, be careful. This is subtraction, right? So just like when we added and subtracted polynomials. If I do 4 minus 3, that gives me 1. And I have -7i minus, right, because we're distributing that negative, a -2i would be -9i. Okay. E might look a little bit trickier, but really you just have to distribute a few things. So remember, when we do PEMDAS, we just make sure that we get rid of those parentheses first. So we get 8 plus 2i. We then distribute this in and get -10i. And here it looks like we're going to have -15 and then I squared. So as we're multiplying on this one, you'll notice that I squared is what I was saying before. The 8 is the real part. That's great. These two are both imaginary, so we can combine those like terms. 2 minus 10 would be -8i. And then we have this third term. Now, because I is not just x, it's not just any number, I represents the square root of -1. Remember that we said on the last page that the square root of -1, I apologize, I'm going to scroll down here, is always equal to -1. I apologize, the square root of -1 squared, or in other words, I squared, will always be -1. So when we come over here and we see an I squared, what we'll do is we'll bring that term down, -15, and we're multiplying it by -1. Or in other words, that becomes a +15, because negative times a negative becomes a +15. So now we have this piece and this piece that add together to get 23, and we get -8i. Now powers of I will always simplify down. So you want to make sure that when you get done, you should never have a whole bunch of terms with complex numbers. they should always simplify down to a single complex number, no matter how many terms you had to start with. Okay, let's see if there were any additional examples. Okay, multiplying complex numbers. So we just did this one a little bit. This one you just treat them like polynomials. So use distribution, FOIL, box method, whatever you need to multiply these. And then make sure again, once you get that I squared, that you're simplifying it all the way down to a single complex number. I should have one real part and one imaginary part. So let's try a couple of these. On example A, we've got 3 plus I multiplying by 4 minus 7i. So again, we're going to distribute, or what we call FOIL. So 3 times 4 is 12. 3 times negative 7i is negative 21i. To finish foiling, we distribute the I into each term. So I times 4 is 4i, and I times negative 7i is negative 7i squared. Now again, as I write this down, I have 12 here. I can combine these two, so negative 21i plus 4i would be minus 17i. And then I have negative 7 times I squared, and just remember I squared is equal to negative 1, so that's really like plus 7 on the end there. We combine the 12 and the 7 to get 19, and we get 19 minus 17i. Very good. Again, if I were to look at B right here is 5i times a negative 3i. So 5 times negative 3 is negative 15. I times I is I squared. Remember, I squared is equal to negative 1. So whenever we see an I squared, we substitute negative 1. And if I have a negative times a negative, that gives me a positive 15. These really can't get any more challenging than that, because you're just foiling or distributing and multiplying in relation to that. Okay, let's do one more. So if I was distributing this one in, 3i times 4 is 12i. 3i times negative 7i is negative 21i squared. Again, here I have 12i minus 21, and I substitute a negative 1 in where I see an I squared. So this is really 12i. Negative 21 times negative 1 is positive 21. To write that in standard form, we generally write the real part first, and then the imaginary part second. So I just switched these around, and that would be our complex number. The last thing on this video I just want to make you aware of is that your calculator does complex operations as well. So this is never something we should get stuck on, and we can always check our answers doing that as well. So if you would like to follow these steps, you can, and it will allow you to do, maybe if you were doing a big one like this. Smaller ones I think are just as fast to multiply through. Just be aware if you're going to, some of the calculators need to be put in complex mode first. So this gives you instructions for doing that. You're going to push the mode button. And then you're going to make sure that you go down until you highlight the A plus BI mode. Then you can go back to the main screen to calculate, and you can enter the expression that you want to simplify. Just remember, when you want to find the I, it's the decimal button. You just have to push second and then the decimal button. So let's try one of these, and I'm not going to even necessarily do one from the notes, but if I open up the calculator here, we could do, again, if you push up here by the blue button, it says mode, and you'll notice if you scroll, or if you go down there, it has different modes that you can find. Now mine looks a little bit different than yours, so I don't know, but you'll notice down here where it says real number, next to yours it should say A plus BI, or in other words, we're in complex mode. The newer calculators will do it without having it in complex mode, so either way you can test it and see if it works. Once it's in complex mode, I can go back to the main screen and I can put in an expression. So if I put parenthesis 5 plus 2, and again the I is the decimal, you just need to push the second button first. So second decimal, and I close that, I can multiply that by 3 minus 2i. Second decimal, and it will calculate that for me there. So I want you to kind of practice both. Definitely work through some of these by hand. You're welcome to use a calculator to check if you have a calculator